Linux mini PCs redefine Edge AI. The BOSGAME VTA-439 demonstrates that open-source hardware and software now enable high-performance AI inference at the edge, but the proliferation of such devices introduces critical remote code execution vulnerabilities. The recent benchmarks of the BOSGAME VTA-439, powered by the Ryzen AI 9 HX470 processor and Radeon 890M graphics, confirm that modern mini PCs are capable of executing demanding AI workloads directly at the network periphery.
This leap in edge AI capability, however, arrives alongside a corresponding expansion of the attack surface. The same Linux ecosystem that drives innovation to open-source repositories and community documentation also inherits systemic security fragilities. The urgency is compounded by the fact that these devices are often deployed in unattended, physically accessible locations, making them prime targets for remote exploitation.
Open source documentation fuels rapid adoption. The wealth of free Linux books and programming resources lowers barriers, yet the same openness amplifies attack surfaces. As catalogued by the Linux Links article, the open source movement has produced an extensive library of free documentation covering everything from shell scripting to deep learning frameworks.
While this democratization of knowledge accelerates the development of AI solutions on hardware like the VTA-439, it simultaneously creates a fragmented security posture. Most tutorials prioritize functionality over hardening, and few guides address the specific risks of remote code execution as seen in edge deployments. Consequently, developers, especially those new to Linux, may inadvertently expose services such as SSH, Jupyter notebooks, or custom AI APIs to the internet without proper authentication or patching.
RCE vulnerabilities in edge AI ecosystems. A deep analysis of how remote code execution threats exploit the gap between powerful hardware and security-literate deployment. The BOSGAME VTA-439 benchmarks reveal outstanding CPU and GPU throughput, making it an attractive platform for real-time inference in IoT, robotics, and surveillance.
Yet the very traits that make it powerful, full Linux compatibility, high connectivity, and support for containers, also create a hostile environment if misconfigured. Attack vectors include unsecured microservice dependencies,
vulnerable Redis or Node.js instances, static credentials in flashed firmware, and exposed debug ports enabled by default in many open-source AI stacks.
These RC pathways allow adversaries to pivot from a single compromised mini PC to entire fleet-level command, leveraging the device's compute power for botnets or cryptojacking without triggering conventional network alerts.
Balancing innovation and security at the edge. The next wave of open-source AI hardware demands a proactive security framework or faces exploitation at scale. The convergence of affordable, powerful Linux mini PCs and accessible open-source AI tools is a strategic boon for research and edge deployment, but it also foretells a wave of large-scale compromises if left unaddressed.
Future risks include orchestrated attacks using supply chain malware embedded in popular AI models or documentation archives, turning the very resources that enable innovation into delivery mechanisms for RCE. To mitigate this, stakeholders must embed security into the documentation lifecycle, for instance, by requiring that all free Linux books and tutorials include a hardening checklist for edge deployments.
Hardware manufacturers like BOSGAME should also ship devices with secure by default configurations and provide automated vulnerability scanning tools. Only then can the promise of open-source AI at the edge be realized without becoming the next frontier of digital conflict.